Okay, one of the last basic operations with vectors is the multiplication by a scalar. And this operation is only a change in the magnitude. The scalar is value with no sense or no direction. It represents only an increase or a decrease in magnitude. Let's say length, distance, force, or something similar. So let's say, for example, that we have vector A and we want to multiply by 2 vector A. That is going to be equal to 2 times the component A sub 1 and 2 times component A sub 2 and 2 times component A sub 3. This applies for the case in the three-dimensional space. If you are working with two-dimensional space, then we will have only a couple of a pair or of components for that vector. So the general expression for this is any constant that multiplies vector A is going to be equal to that constant times a component from C, the constant times component Y, and the constant times component Z. Okay, if we draw this, uh, let's draw little vectors here. So this is vector number 1, and let's figure here some examples. So graphically, if this is vector A, and this is the length or the modulus of vector A, 2A will be 2 times the length of A. So in this case, more or less, this could be 0.5 times A. And in this case, let's say that this will be minus A. So if we multiply the vector for a negative quantity, we will have the vector pointing in the opposite direction. And this is geometrically explaining the multiplication of a vector by a scalar. So at this time, we covered the most basic vector operations. So let's do a class example. So we can close this topic, and let's do a class exercise on this. Okay. Um, let's say we have a couple of vectors. Let's see, we have these guys, vector A. Let's say the components for this vector A are 4, 0, 3, and vector B, this is minus 2, 1, 5. Okay, and let's calculate first the modulus. Let's calculate the length of A. Let's calculate the length of the modulus for B. Let's do the addition A plus B, and let's do an exercise here. 2 times vector A plus 5 times um, vector B. So let's apply what we have learned. Let's start with this one, vector A. So for vector A, have the components for that vector are uh, vector A equals 4, 0, 3. Okay, if you remember the formula for the distance, then we can express this length of the vector in this. So this will be 4 squared plus 0 squared plus 3 squared, and we calculate the square root of that. So in this case, that's equal 4 to the square is 16, then 0 to the square is 0, and 3 square is 9. We'll still having here this root square, and this equals the square root of 25. Solving this in approximate form, this equals 5. So the length of vector A equals 5. Okay, let's do the second one. This vector B equals -2, 1, 5, and the length or the modulus for this vector B is going to be equal to -2 squared plus 1 to the square plus 5 to the square, and we're going to take the square root of that, and this equals 4 plus 1 plus 5 to the square is 25, and we'll take it the square root of that, and that is the square root of 30. So this is an approximate result of 5.4772. So for this length of B, the exact result for this result is square root of 30. Okay, let's do the third one. A plus B. So vector A plus vector B. If you remember, we're going to add each one of these components by axis. So this is equal to 4 plus -2, 0 plus 1, and 3 plus 5. Okay, and that is equal to 2, 1, 8. Okay, so this result is equal to 2, 1, 8. And that's the result of the addition for A and B. Let's do the last one. This is a product multiplication by a scalar, and then the addition of the two results. So let's write it here. It's going to be 2 times A plus 5 times B equals 2 times the first vector, which is 4, 0, 3, plus 5 times the second vector, which is 2, comma 1, comma 5. Okay, if we do the multiplication, 2 times 4 is equals 8. 2 times 0 is 0, and 2 times 3 equals 6. So this is the first one. And let's add here the summation symbol. 5 times minus 2 equals minus 10. 5 times 1 equals 5. 5 times 5 equals 25. Adding all this, 8 plus minus 10, 0 plus 5, and 6 plus 25, we will come up with minus 2, 5, 31. So the result for this operation, 2 times A plus 5 times B equals minus 2, comma 5, comma 31. And uh, with the basic operations, this is the first class exercise. Please uh, don't forget that we can translate this result to the standard basis vectors. In this case, please don't forget that this will be equal to minus 2 times I plus 5 times J plus 31 times K. It's the same. The only change is that we are replacing the uh, component notation by a standard basis vectorial notation. So all the operations will remain the same. The only thing that we are changing here is the way that we are uh, using the notation to describe this this vector using this standard basis notation.